Hey guys, it's Vince. Today in this video we are continuing with yet again part number 14 of CNC controller failures, and what makes this one most interesting is this guy was in a previous video of mine and he still is building systems incorrectly. That being said, let me draw your attention to a copyright takedown request that I received based on one of my videos. And I'm showing you guys this because I know some of you out there will be doing channels, whoever you may be, and you're under the influence that you can use YouTube to control people seeing what you're doing incorrectly. Well, let me clue you in on something and read carefully. We received the copyright infringement notification below regarding your video. We believe your content is protected by fair use, fair dealing, or a similar exception to a copyright protection. We are writing to let you know we do not plan to remove your video at this time. Now, I always stay anonymous as to who this person is, except now. When you come at me with this, I'm going to disclose your information. This was username Travis Mitchell. Email address is right here. And you can see he was one of the guys that actually did the Masso build that my video was so popular with. I get questions on it all the time. And he was the one that thought that by going to YouTube and filing a copyright, that YouTube would protect him, basically providing end users misinformation. Guess what? It doesn't happen. He needs to review Fair Use Act. Anything disclosed for educational purpose, which is exactly what I'm doing, falls under that. YouTube's seen it, YouTube followed it, and I'm letting all of you know. I realize many of you are out there to learn, but some are end users posting content, and this is important for them to see, because just because you're on YouTube and you generate content as a content creator does not mean you're actually skilled in what you're doing. If you provide the wrong information based on CNC genre and I find it, this is what you're going to get. So my suggestion is pay close attention and let's delve right into the video. Okay guys, you can see right here we're already using a wood backboard, which is incorrect. Looks like he's using MDF. He's mounting the VFD along with other electronics. So what we're going to do is hop right over and check out the user's manual for the HY VFD to give you a little insight on what's really going on here. Okay guys, we are once again inside of Wanyang's VFD user's manual. Now, when I say that, you can see the PDF up here. We've got precautions on wiring, which is section 4. And again, I'm just going to point out and highlight the key areas that you guys should be aware of. Now, that being said, it would take me hours to go through the entire manual, but going through the key sections that I'm speaking about should make you aware of reading the entire user's manual and be responsible for the electronics you're working with. This end user, even though he's not US based, refuses to do this. So what we're going to do is I'm going to point out here that up here it says, while wiring, the sizes and specifications of wires should be selected and the wiring should be executed according to the electrical engineering regulations to ensure the safety. And of course, the Chinese sometimes have grammatical errors, mainly because this is their second language. I, like many of you, wish we could speak Mandarin as good as they can speak English. So before we nitpick the manual, let's take into account what's being said and try to digest it fully, because this is where most end users, this one namely in the video, is going wrong. I've seen this done numerous times. Again, it is better to shield wire or wiring conduit for power cord and ground the shielded layer or two ends of the wire conduit. Now, wire conduit is not the cable itself, guys. Okay, so we have to keep that in mind. Now, how do I know that? Well, let's come down here. And you can see, once again, it's showing you the proper grounding method. Do avoid sharing grounding wire with other large power equipment such as an electric welder. And it goes on, power machine, etc. The grounding wire should be kept away from the power supply wires for large power equipment. Why? We want proper dissipation. You can see right here, this is considered good. This is considered good. This is not good. Why? Because we have a loop. This lead right here generates a loop, gentlemen. So what we need to do is pay close attention to detail of what we're working with. Also, it states the grounding wire must be as short as possible. Why? Because if the wire is short, we reduce our resistance. The lower our resistance, the better dissipation of ground we have. Once again, don't take my word for this, guys. I mean, regardless of the 100K subs, I know many of you out there are, in disbelief. I've got 440 videos, 450 videos. If you think that social knowledge is all BS, do your own research. See if what I'm talking about is fact. It's fact. I'm telling you it is. The control circuit wiring, signal wire, the signal line should be separately laid in different conduit with the main circuit wire to avoid any possible interference. Now that's just fancy talk for we try to keep our signal wire separate. Why? Because once again, we don't want to have possible interference. Please use shielded cable with the size of 0.5 to 2 millimeter for signal wires. Now you can go larger than that, but optimally you don't want to go smaller than 0.5 mil. Now guys will say, well, what does that translate to 8WG rating? Well, typically for shielded cable, as far as signals, I wouldn't go less than 20 gauge. That's my own personal preference. You can probably get away with going to 22. I just don't recommend it. First of all, the longer you go with the cable, you're going to have voltage drop. That means your signal reception will be less. So again, we want to pay attention to details. Will it cost you more money? Yes. Will it be done right? Yes. Are you going to have to digest that and understand that when you develop your budget? Yes. And the big thing is that rather than tell me you're a hobbyist, which really means nothing, you still expect a machine that's accurate. Therefore, you have to build it correctly. Use the control terminals on the control panel correctly according to your needs. That makes logical sense. Everything here really is pretty basic. Once again, if you understand what we're working with. And this is the key area, the grounding. And of course, coming up here and making sure that logic is met. We got output wires mustn't be in touch of the metal part of the inverter enclosure or it will result in an earth short circuit, of course. Let's see, phase shifting capacitors, LC, RC, noise filters, etc. can never be connected to the output terminals of the inverter. The main circuit wire must be and this is interesting, the main circuit wire must be enough far away from other control equipment. Why? Because we don't want noise interference. When the wiring between the inverter and the motor exceeds 15 meters for 220 volt class or 30 meters for 380 volt class, which once again would be single phase, 220 or three phase, much higher dV/dt will be produced inside the coil of the motor, which will cause a destruction to the interlay or insulation of the motor. Please use a dedicated AC motor for the inverter or add a reactor at the inverter. So looking at this, if you guys don't understand this in any capacity, hire someone that does, whether it be an engineer like myself or whether it be an electrician. Now, I'm going to tell you right now, all electricians are not created equal, mainly because they may not be an industrial electrician. These are things you're going to pay more for, so keep that in mind. If you go to a residential electrician and he says, I've never seen this before, don't be surprised, guys. You have to look at what you're working with, and that's why I say take your time. But this is critical to understand. Another area we should discuss, grounding terminal E, be sure to make correct grounding, 220 volt class. The third grounding method, grounding resistance should be 100 ohms or lower. 380 volt class, special third grounding method, grounding resistance should be 10 ohms or lower. Now, of course, three-phase, I'm going to tell you right now, regardless of the phase we're using in terms of three-phase, single-phase, I recommend staying as low as possible with your grounding. The lower the resistance, the better grounding you have. It's simple as that. So when we see 100 here, all you guys got to realize is lower numbers are better. So let's say you get a 70, you're right on point. You get a 60, even better. You get a 50, great. I mean, that's really what you're looking at. Many of you aren't using three-phase, so it's not something to worry about, but keep in mind, this is where we're going with this. And again, focus on the user's manual. You guys can tell I removed the background audio because first of all, it's distracting. And again, dealing with a content creator, they're more worried about YouTube's algorithm to boost their video than to give proper information. So you can see right now, he's going to go through and do the accelerated assembly. A lot of these guys do that, and we'll cover it as he finishes up. I, like many of you, find it super interesting that the HY user's manual is right there for a split second, yet following his mounting procedure into this enclosure reflects he never even read what I just showed you. Okay, so it's apparent we've already covered the VFD issues. Again, no double shielded spindle cable. Nothing is grounded. We already see that he's just worried about mounting the electronics, as we see here. He thinks just by wiring everything in terms of just connecting point A to point B to a terminal block, everything is done. This is nothing new that we've seen in all my CNC fail videos. There's no ground bus. There's nothing really. There's no ferrites added in between the leads going from his actual drives to any of his electronics. Guys, this once again is just content. It is not a correctly built controller. And you will hear that he is using closed loop drives. It is completely irrelevant of what kind of drives he's using. This is not built correctly, nor is it built safe in terms of it being built inside of a wood enclosure, which if you guys are in the US, and I'm sure it's the same in Europe, if you have any problems with fires, your insurance company will not cover you. I'm telling you right now, proceed with caution.
So here we are now on the main side of the electronics cabinet, and as you can hear, the VFD is quite loud, so I'm actually going to go ahead and turn it off for now. Right now we just have this very precarious switch here, because it's not mounted yet, which is definitely far from ideal, but this will later live in a door somewhere around here and be quite convenient. So I'm gonna kind of split this in two parts. First, I'm gonna just give you a very brief overview over everything to see like what I'm using, what components, since I think that's gonna be most interesting for a lot of people. And after that, I will go into the very details of configuring like which component to wire up how, because I had quite some troubles, and I'll go into that in a second. At the heart of everything, the controller I'm using is an NVEM V2 from Novusun. This is kind of like mid-range Mach 3 controller off of AliExpress. It's not the like super cheap parallel port kind of deal, but it's also nothing fancy. The controller itself is quite decent, but the manual for it is horrific.
It's always interesting, guys, how many of these content creators follow a pattern with their channel. Once again, this individual has not done this once, he's done this twice, and he's discussing now how his controller build is decent. I think we've already defined that it's not decent, and this is definitely not best practice, and you guys most likely will have issues with this controller. That being said, when he's discussing components coming from China not having high-end user manuals, that's because you're buying direct from a factory. So if you're buying direct from a factory, once again, they are assuming you're a vendor or you're someone going to provide first-hand knowledge of their components. If you're expecting them to give you high-end manuals, you guys are sorely mistaken, and you might as well just forget about direct support. So this, once again, is why you will pay a vendor like myself to actually go through, decipher the information, provide you the correct information so you have the knowledge to build your controller correctly.
In some areas it is missing very crucial details, while in other areas the details that are mentioned are just plain wrong. But I will go more into detail on that later. Then connected to that, we have the 4 motor drivers for the closed loop stepper motors. They are also very generic from China. The model number is HBS 57H. They do not have any brand name on them, but they work quite well as long as you hook up everything correctly.
Hooking up everything correctly means using all the correct components. He never discussed double shielded cable. He never discussed proper mounting as far as using an electrical enclosure that is metal. The VFD we know is mounted incorrectly, guys. I'm telling you, be very, very cautious of what these guys, and once again, they're called content creators, deem as being hooked up correctly. Assembling a system, I've said it in all my videos, and simply connecting point A to point B is not assembled correctly.
So once again, there is not really any manual, and hooking up all the encoder signals correctly is very important, otherwise they just don't work. They are labeled on the motors, which color does what, but just in Chinese. So either you'll have to translate that, or I will show you later what I found out through watching somebody else's video. Then for the spindle itself, here is the VFD for it. It's a Huanyang VFD, so also like not the very cheapest knockoff, but also nothing fancy once again. It does its job and is controlling a 2.2 kilowatt air-cooled spindle. To power everything for the stepper motors, we have this 60 volt power supply here.
The chassis he's using, guys, 60 volts is massive, and honestly, he's never going to get the benefit of that. 48 volts typically is fine for a chassis, easily within a 4 by 8 foot range. So keep that in mind. Don't pay more for stuff you don't need. Once again, this is where end users, aka content creators, go wrong. Well, they're telling you what they chose, but they're not explaining, is it required, is it not required? You're going to pay more for stuff you're never going to see the difference in.
That gives juice to them, and up here 24 volt for all the logic. On the input here, just a simple fuse, some distribution blocks, and here I have 2 relays as well, where I will be able to hook up like any sort of coolant or anything like that. I've not hooked anything up to them yet, but well, I'll definitely have some sort of dust collection, and I will be able to trigger that through that. And then connected through this Ethernet cable here is just an old laptop. It's actually the same tablet that I'm using to control my other CNC. I might get a second controller at some point, but for now this does the job. And on there is running Mach 3. I think the way I'm going to do it is that at the very end of the video I will quickly go over to Mach 3 and show you everything there. So I'll of course have timestamps down below if you want to jump to that. Alright, so story time. The reason why it took this long for this video to come out, it was supposed to come out like right the week after the previous CNC video, and I had most of the electronics assembled and everything. But getting this stuff to work ended up being a challenge on every single step. First challenge was getting the controller to talk to the computer. In the manual for the controller, they tell you to either connect it through a router, which is the preferred method according to them, or connect it up directly to a computer, just into the Ethernet port. Now, I don't know what kind of magic they are using, but definitely connecting it directly should be much the preferred method, as there is no chance for any packets to get lost or anything like that on the way.
Selecting an Ethernet controller, guys, is definitely going to provide you the most stable signals. He's using 24 volt for logic, which once again, the higher the voltage, the more stable your signals. And keep in mind what he's discussing now about going through hurdles with literature once again, and also discussing about how going through a router is not best practice. That's true. You want to hook it up directly to your PC. A lot of guys want to make things wireless. They actually misconstrued what they're building. They'll think that working with computers translates into a stable controller, and it's just not it, guys. You really want to make sure that you have your controller hooked directly to your PC, and once you have stability with that, if you want to test hooking it up to a router, that's fine. Do not ever try to implement Wi-Fi, because if you lose Wi-Fi connection in a file transfer, you can have all kinds of crazy things happen. I've had many clients experience that. I'm telling you, a hardwire connection when you're doing production is the safest way to go.
Now, it did come with a Mach 3 install, which was largely pre-configured, which is quite great. You don't like all the ports and pins are already correctly in there, and it is also activated, at least in some fashion. Like, you don't need to buy a Mach 3 license. How legit this license is, I don't know, but it came with it, so I'm going to roll with it.
If you guys receive any software with your system, namely Mach 3, CAM software, whatever it may be, and it's coming from China, most all of it is pirated. There are a few companies that may be legit, but take my word for it, most Mach 3 licenses that come bundled with hardware are cracked in some format, and they will be missing features or cause problems. I can't tell you how many soft limit clients I've had tell me that I can't get your video to work, and the first thing we go over is, where'd you get your license? Oh, it came from overseas. Well, guess what? Odds are it's not going to work. There's a reason Mach 3 costs what it does. Once again, if you try to go cheapo on it and you think you're going to get a free lunch, it doesn't usually happen. Be careful. I'm also shocked that a content creator would openly admit to using pirated software, which still is technically illegal. So just be careful once again of what you're working with. Not so much for the fact that you're looking at the best bargain, but look for the future of you want a robot that can produce an income that's stable. Okay guys, I've discussed this before. Voltage negative on your power supply is not a ground. You can see he's using a shielded cable here, it looks like, for his motor cable. But once again, it's not connected properly at all. It's interesting again to bring up that he never discusses shielded cables at all in his components. He just discusses the electronics themselves. We see the shield drain here, which is not terminated properly. He has ferrules on everything else. There's no ferrule here. And this is just bare and basically just exposed. Guys, please be careful of who you're working with. If you're going to terminate a shield drain correctly, it should be done using a ground bus bar. Okay, I offer them. I've shown them in my videos. I will put a link in the video description of one of my pro builds so you can see an IDS system, which stands for individual drive system, and you can see exactly how to do this. This is not done correctly, and again, we have to be aware of content creators. That's what you're dealing with here. Once again, guys, we see here what's very similar on many of these videos that content creators put out, in that they're unaware of how to use a terminal block correctly. You see we have a terminal block on our VFD under DCM, and we have two ferrules inserted into the terminal block. And common logic is if you don't have a ferrule properly seated like the ones on the right, then why would you continue to do this, and why would you post it? Again, this logic I will never understand. I've seen it time and time again, but we need to start with best practice. This is unsafe, and this should never be done.
You need to hook up the forwards, the reverse, and the voltage in, which is for the speed.
Okay guys, that wraps up another video. I want to thank all my subscribers and everybody who's been supporting me over the years. You guys have been great. If you got something out of the video, please hit that subscribe button, hit the bell. It really does me a favor, does the channel a favor. And keep in mind that I will keep these videos coming because there are unscrupulous content creators, and unfortunately they'll do anything to get the algorithm to get that video picked up, and so more and more end users get this information in terms of what not to do. And unfortunately, I'm doing my best to expose as much as I can, but I think with all of my CNC fail videos, even if you watch two, you'll realize real quick just how easy it is to be put off track of building that machine you're looking to make. And it unfortunately doesn't take much, and it will cost you more money in the long run, so please be careful. Take care.